Hi everyone, welcome to the One Code Camp channel. In this video, we are diving deep into the world of Node.js Native Modules. Specifically, we'll be exploring the powerful path and HTTP modules. So, if you've ever wondered how to manipulate the paths or create a blasting HTTP server in Node.js, you are in the right place. So, come on in and let's get started.
Good day, my fellow developers. Once again, this is Ron Gilbert, and today we're going to talk about two native modules, the path module and the HTTP module. I hate to keep you waiting, so let's get started. The path module is a built-in module in Node.js that provides utilities for working with file and directory paths. It offers a set of functions that help you manipulate and manage paths in a platform-independent and consistent manner, regardless of the operating system you are working on. The path module is particularly useful when dealing with file operations such as reading, writing, or manipulating files and directory. It ensures that your code is compatible across different platforms such as Windows, macOS, and Linux, which might have different conventions for representing file paths. Now that we have a clear understanding of the Node.js path module, let's push it to VS Code and showcase the various methods that we can utilize using this native module. The first thing that we're going to do is create a folder. As per mine, I gave it a name, Node.js. After that, let's create a new JavaScript file and name it path.js. To begin with, let's import the path module using the require function. To do this, let's declare a constant variable and name it path. Followed by an equal sign, and after that, let's use the require keyword to import the path module. The first method that we're going to try is the process of joining the path segments. The join method constructs a path by joining given path segments together using the correct platform-specific separator. To use this, first, let's declare a constant variable and name it join path. Followed by an equal sign. Then let's type path, period, followed by the method join. Inside this method, let's type the segments that we would like to join. Let's encapsulate them using a string quotation and should be separated by comma. Once we're done, let's log it to the console. Let us just add a message saying that this is the join path. And let's insert the join path variable. Now that we're all set and done, let's open the terminal. Let us run this script using the node keyword followed by space and the name of our file. And there you have it, we have successfully joined segmented paths. The next method that we're going to use is the resolving paths. Resolving paths refers to the process of determining the full and absolute path of a file or directory based on a given relative path. In other words, it helps you convert a partial or relative path into a complete and absolute path. To do this, let's declare a constant variable and name it resolved path. Again, let's assign a value to this variable, followed by the variable path and the method resolve. To represent a relative path, let's say for example, our path will go up one direction, then enters the folder directory, and finally points to the file.txt within the directory. Now let's log this to the console. Let us just add a string saying that this is the result path. Then let's insert the result path variable. Let us also comment this out. Then let's run this script to the console. And there you have it. This example showcases how the path.result function takes these relative segments and converts them into an absolute path based on the current working directory. Our next example is the process of getting the file information. Let us just comment this out. For this process, we're going to use the parse function. The parse function parses a path into components such as directory, file name, and extension. Let's create a constant variable and name it file path this time. For this one, let us type the file directory, and let's assume that it is under the root, inside the folder, and the name is file.txt. After that, let's declare another constant variable and name it file info, followed by the variable path, and let's use the method parse. Inside this, let us pass the parameter file path. Finally, let's log this script to the console. Let us just type a script saying that this is the file info. And let us pass the file info variable. Let us now run this script using the terminal. Let us just clear the logs first. Now let's try to run it. And there you have it. Using the parse method, we are able to get the file info of our file. These informations include the root, directory, base of the file, extension, and the name of the file. Now for our next example, we will use the normalize function to normalize a path. When working with paths, it's possible to encounter paths that contain special symbols like period and double period. These symbols are used to represent specific directory locations. 1 dot or period represents the current directory, while 2 dot or 2 period represents the parent directory. The normalize function is designed to handle these paths that include these special symbols and resolve them to create a more standardized and readable path. It takes a path as input and performs an operation. To further understand this, let's proceed with the example. Let me just comment this out. And let's add another comment, normalizing paths. First, let us declare a constant variable. Let's name the variable file path, followed by an equal sign to initiate a value. Then let's type path followed by the normalize method. Inside this method, let us pass a path that contains a special symbol like dot or double dot. Once we're done assigning the path, we're going to log it to the console. To do this, let's type console.log. Let's add a string saying that this is the normalized path. Let's add a comma separator. And together with this, let us pass in the file path variable. Actually, let's rename this into normalized path. And let's pass this normalized path here. And finally, let's run this script. There you have it, we have successfully normalized a path. By using the normalize function, you ensure that your paths are consistent, readable, and accurately represent the actual file or directory locations. This is especially important when you're constructing paths dynamically or processing paths that might include special symbols. The function helps avoid potential confusion and ensures that your code operates with the correct and normalized paths. Now let's proceed to our next method operation, and that is the process of extracting path components. To start with, let me just comment this out. Let us also add a comment extracting path components. First, let's declare a constant variable. Let's name it directory name, followed by an equal sign, and then again let's type the path variable, followed by the method dir name, or short for directory name. Inside this method, we will pass a file path, so let's copy the previous file path that we have created. Let's paste it here. And let us pass it as a parameter. Let me just remove the typographical errors. Now that we're all set, let's try to log this into the console. Let us pass in the directory name. Now let's run this script. And you can see that we have successfully extracted the directory name of this file path. Now let's try to extract the base name of this file path. To do this, let's declare another constant variable. Let's call it base name this time. To extract the base name, we will use the base name function. And again, we're going to pass in the file path parameter. Then let's log it to the console. Let us type in a string base name. Followed by a comma separator, then let's pass in the base name variable. Let us just clear the logs. Then let's run our script using the terminal. And there you have it. We have successfully extracted the base name of this path using the base name function from the path module. We were also able to extract the directory name using the dir name function from the path module. These functions collectively assist in organizing, manipulating, and managing files in your Node.js applications. That concludes our discussion for path module. But before we move on to the next topic, I want to let you know that while we've covered some of the essential and commonly used path manipulation operations, in Node.js, there are actually more functions and concepts available for more advanced path handling tasks. If you're eager to explore further, I encourage you to check out the Node.js documentation and resources available online. In this website, you'll find a wealth of information on other functions that is incredibly useful as you become more comfortable with working with paths in your Node.js applications. Moving on to the next native module that we will discuss, the next module that we will discuss is the HTTP Native Modules. The HTTP Native Module in Node.js is a built-in module that provides a set of functionalities for creating and interacting with HTTP servers and clients. HTTP is the protocol used for communication between web browsers and servers, making the HTTP module a fundamental tool for web development in Node.js. With this module, you can create a server that listens for incoming requests from clients and sends out corresponding responses. This allows you to build web applications, APIs, and other network services that can handle user interactions and deliver dynamic content. In essence, the HTTP module is a foundational component of Node.js web development that empowers developers to handle the intricacies of web communication, making it an essential tool for building modern and interactive web applications. To make a sample application of this module, let's go back to the VS Code. First, let's create a new file and let's name it server.js. After that, we will import the HTTP module using the require method in order for us to gain access to this module. First, let's declare a constant variable. Let's name it HTTP, followed by an equal sign, and let's use the require keyword to import the HTTP module. Now that we have an access to the HTTP module, let's declare another constant variable and name it server, followed by an equal sign, http.createServer. Now inside this method, let us pass a function as an argument. This callback function should accept two parameters, the request and the response. Now let's use the writeHead method to set the response of the header. Let's pass in a status code 200. This status code means that our response is successful. After that, let's set the content type. This will indicate that our response body will contain an HTML content. Now let's use the rest.end method to send the final response data back to the client. We will send a hello world header to the client. Finally, we will use the listen method to listen to the server. Then let's specify the port that we will use. In this case, let's use 8080. Finally, our server is all set. Let us now try and run this script. Now that our server is running, let us now open our web browser. Let's navigate to the URL where our server is running. Just type localhost:8080. And that's it, you have successfully run your HTTP server script and access the response in your web browser. This simple example demonstrates how you can create a basic HTTP server using Node.js to handle incoming requests and generate responses. And there you have it, the essentials of using native modules and delivering into the world of HTTP. Once again, this is Ron. Thank you for staying with us and see you again in the next video.